How fast can I windsurf? What does physics say? Being the fastest sailor on land or water is apparently a basic human need. There are many examples from the past that show how much effort was put into the design, construction and test conditions in order to achieve this. Recently, the media has been discussing the possibilities of what speeds can still be achieved in windsurfing. It can be observed that there are many ideas that correspond more to wishful thinking than to the physical possibilities, hence this video, which will show which special physical factors play a role in sailing and windsurfing and which maximum speeds can be achieved under which courses and wind forces. To determine the sailing speed, the forces and moments involved simply need to be set in equilibrium. The sailing speed can be determined from these conditions. Basically, all sail constructions have the problem that the sail force is generated far above the hull in the sail and not in the plane of the vehicle. In relation to the plane in which the boat floats, this results in a moment, force times lever arm, that tilts the boat, which is known as heeling. The heeling moment must be compensated for by a counter-moment, which in the case of sailing boats or yachts is the weight moment, as the weight force is compensated for by the resulting lever arm. This is the so-called righting moment. Yachts cannot sail without heeling, as the lever arm is only created when the yacht is tilted to compensate for the moment due to the weight. This means that the moment equalization in all sailboat designs is generated by a counterweight moment. Examples of this are all land yachts or ice sailors. The sailing moment is either compensated by a boom with additional weight, such as the Horonuku land yacht, which has a boom of 26 feet and a weight of 2,205 pounds. This allows the yacht to sail upright at extremely high sailing forces. The world record achieved with this yacht is 121.8 knots in 20 knots of wind. Alternatively, an outrigger is used, via which the weight of the boat generates the compensating moment. The same principle applies to sailing yachts. Either outriggers are used as in the catamaran or fold out additional weights on the keel. Yachts for the America's Cup, such as the AC-75 class, use fold-out foils that shift the buoyancy point and thus generate a weight moment. Let's move on to windsurfing. The special feature of a windsurf construction with a sail or kite is that the rigid connection between the mast and the hull is eliminated and replaced by a three-axis joint, the power joint. This means that torques can no longer be transmitted to the board, but only forces that are transmitted via the mast foot and the rider's feet. This makes it possible for the sail and board to move independently, making it possible, for example, to lean into a turn, as when riding a motorcycle. The disadvantage of windsurfing is that, unlike other vehicles, the momentum is compensated solely by the rider's weight. This means that the sail power is absolutely limited by the rider's weight. The sail size and the angle of attack of the sail is adapted to the wind conditions so that the sail moment is always equal to the weight moment of the body. Solutions with kite and/or foil do not change this. Foils only change the drag behavior of the board. This shows that the drag of a board in planing condition at high speeds has less drag than a foil. Riding results also show this. The world record for a windsurf board with a fin over a nautical mile is 8 knots faster than on a foil at the same conditions. That's a lot. Furthermore, foils need deeper water, so that the channel in Namibia, for example, cannot be used for foils. Then there are special designs, such as the Sail Rocket 2, where the design avoids a sail moment. Due to the arrangement of the inclined sail on a boom, the line of action of the sail force passes through the overall center of gravity of the vehicle. The fin, which is also inclined, compensates not only for the lateral force but also for the sail lift. This means that the sail force is not limited and can theoretically be increased to any value by increasing the sail area. In the SP-80 project, the weight of the vehicle is supported by sliding bodies as with the Sail Rocket 2. The Sirocco project aims to position the hull in the air to reduce drag. However, there will be some problems with stabilization around the vertical axis and maintaining the height. But back to the topic, determining the speed of windsurfing. The image shows the historical progression of world records achieved with windsurfing boards from 1979 to the present day. It should be noted that the world records since 2012 have all been achieved in a specially built speed channel near Lüderitz in Namibia. Above all, the channel provides a smooth water surface and strong winds and a more or less optimal course to the wind. The world sailing record of 65.45 knots in open waters was achieved in 2012 with this concept. However, the aim is to break this record again. The SP-80 and Sirocco projects are currently underway with the aim of raising the world record to at least 80 knots. In both projects, the sail is replaced by a kite, which allows the sail area and thus the sail power to be increased without any design changes on the board. The SP-80 and Sirocco projects are still wishful thinking. SailRocket 2 is the fastest sailing yacht on the water, 56 knots slower than the land yacht. Icegler, Kiter and Windsurfer are over 50 knots, with Windfoiler and Wingfoiler some way behind.